All right, so on Monday, we learned about perpendicular bisectors. And yesterday, we learned that the three perpendicular bisectors on a triangle will all come together and touch each other in a single point. That point of concurrency is called the circumcenter. Today, we are going to talk about angle bisectors and what we call the place where the three angle bisectors of a triangle intersect each other. An angle bisector is a segment, line, or ray that splits an angle into two smaller congruent angles. An angle bisector is a segment, line, or ray that splits an angle into two smaller congruent angles. And we have a picture of this off to the side over here. Right here. Do you guys see those two congruence markings on the angles, those two arc markings in there? Let's go ahead and draw them in a little bit clearer. There's an arc marking there and an arc marking here. Because these two angles are congruent, that means that this ray right here, ray AB, is an angle bisector. So that's the first thing that we're going to write down over here. Ray AB is an angle bisector. In my picture, there are two segments drawn in going from point B to point Q and from point B to point P. If I have a point on the angle bisector and I draw a segment from the angle bisector to the sides of the original angle, then those segments are congruent. So segment QB is congruent to segment PB. Let's write that idea down, and then we'll write our congruence. If a point on the angle bisector and the segment drawn in there is perpendicular to the sides of the original angle, then those segments are congruent. So taking that idea and writing it down as a congruence statement, we've marked it on the picture over here that segment QB is congruent to segment PB. And if the segments are congruent, that means they have equal measurements. So the length of segment QB is equal to the length of segment PB. Some other things that I can write down based on observations from the picture. Because ray AB is an angle bisector, angle QAB is congruent to angle PAB, which, similar to my segments, if I have congruent angles, that means the measurements of the angles are congruent. So the measurement of angle QAB is equal to the measurement of angle PAB. Because these two little angles are congruent, that means the measure of angle QAB is half of the big angle, angle QAP. Same thing is true for the other little angle, angle PAB is half of the big angle QAP. Because these little angles are half of the big angle, if I know how big one of the little angles is, I can double it to get the measurement of the big angle. So if I do 2 times the measurement of angle QAB, that would give me the measurement of angle QAP. Or I could do it times the other little angle, 2 times the measurement of angle PAB is equal to the measurement of angle QAP. There's one more observation that I can make. Similar to when I had perpendicular bisectors, because perpendicular gave me these right angles, when I draw in an angle bisector, and then I draw a segment from the angle bisector to the original angle, and I make a right angle right there, I create this right triangle. There's something that we used a whole bunch yesterday when we had right triangles and we wanted to find missing sides. What did we use yesterday? We did use the square root. That wasn't the formula, but that was part of the solving process. What was the formula that we used when we had these right triangles and we wanted to find missing sides? Starts with a P. Pythagorean theorem, yes. Pythagorean theorem is a squared plus b squared equals c squared. And c has to be the hypotenuse of the right triangle. This yellow triangle right here, which side is the hypotenuse? Which side of the yellow triangle is the hypotenuse? AB, opposite the right angle, is the hypotenuse. So those other two sides would go in for A and for B in my a squared plus b squared equals c squared. So I could say AP squared plus PB squared equals AB squared. That's my Pythagorean theorem. Right. Let's look at the first example where we're going to use these properties to solve some problems. I'm going to leave this up for just a moment, and then I'm going to go to the next screen. We will solve a problem. You guys ready? Let's go check out example number 2. It says find QT. So I noticed something when I'm looking at the picture. Do you guys see these little arc markings down here in the corner by R? Yes. Thank you, Ashley. What do those little arc markings in the corner mean? What do those arc markings mean? Is it the same arc marking? What do these mean? Why do we put arc markings in angles like this? They're the same. They are congruent. These two angles are congruent. So if those two angles are congruent, what is this ray RT called? If these two little angles down here are congruent, they're the same size, what do we call the ray that is going right between them? An angle bisector. Point T is on that angle bisector. And then we've drawn in a segment from T to Q and from T to S. And where it hits the side of the angle, it's making a right angle. So what does that mean about QT and TS? They are congruent. These two segments are congruent. So segment QT is congruent to segment TS. That means the measurement of segment QT is equal to the measurement of segment TS. According to the picture, how big is segment QT? 4x plus 8. How big is segment TS? 9x minus 7. We're going to solve this for x now, so I'm going to minus 4 from both sides. So that would give me 8 equals 9x minus 7. Or sorry, not 8. What is 9 minus 4? Come on, guys. What is 9 minus 4? 5. Thank you. Then we're going to add 7 to both sides. What is 8 plus 7? 15. So 15 equals 5x. Then I divide both sides by 5. And that means x is how big? X is 3. Is that what they asked me to find in this problem, though? No. What was I supposed to find? QT. Well, QT, according to the picture, is how big? 4x plus 8. We're going to replace x with 3. So I have 4 times 3 plus 8. What is 4 times 3? 12. And what is 12 plus 8? 20. So QT is 20. All right. Let's look at number 3. We're going to find the length of SP. First thing I notice about the picture is these arc markings down here by J. What do those arc markings mean? Congruent. These two angles here are congruent. So what do we call the ray that's right in between them then? An angle bisector. Because JS is an angle bisector, S is on the angle bisector, and we've drawn in segments from S to M and from S to P, and it makes right angles where it hits the sides of the original angle. What does that mean about SM and SP? They are congruent. SM is congruent to SP. That means the length of SM is equal to the length of SP. How big is SM? 3x plus 5. How big is SP? 6x minus 7. We're going to solve this for x, so I'm going to minus 3x from both sides. That would give me 5 equals 3x minus 7. Then I'm going to add 7 to both sides. What is 5 plus 7? 12. So I have 12 equals 3x. And then I'm going to divide both sides by 3. What is 12 divided by 3? 4. So I get 4 equals x. But I was asked to find what? SP. Well, according to the picture, SP is how big? 6x minus 7. So in the place of x, I'm going to put 4. So 6 times 4 minus 7. What is 6 times 4? 24. And 24 minus 7 is how much? What is 24 minus 7? 17. Beautiful. All right, let's flip the page. Let's go look at example number 4 now. Before I add any of the given information, I see these two little arc markings right here, which means what about these two angles? They are congruent. So that means that this ray right here is called what? An angle bisector, yes. Because that's an angle bisector, and segment BQ is perpendicular to the original angle, and segment BP is also perpendicular to the original angle. What does that mean about QB and BP? They are congruent. All right, so let's add the information that they gave us now. It says that QB is 3x minus 5. 3x minus 5. It says that angle PAB is 29 degrees. PAB would be this right here. That is 29 degrees. And then it says that segment PB is x plus 17. First thing they want me to find is x. How can I find x? What can I do to find x? Where is X in the picture? Where is X in the picture? Yes, QB and BP. What do we know about those two segments? They are congruent. QB is congruent to PB. If the segments are congruent, what does that mean about their measurements? They're equal. So the measurement of segment QB is equal to the measurement of segment PB. How big is segment QB? 3x minus 5 equals, how big is segment PB? X plus 17. Let's solve this for x now. So I'm going to minus x from both sides. 3x minus x gives me 2x. So I have 2x minus 5 equals 17. Then I'm going to add 5 to both sides. What is 17 plus 5? What is 17 plus 5? 22. Then we divide both sides by 2. How big is x? How big is x? $11. X is 11. The next thing they wanted me to find is QB. Well, according to the picture, QB is 3x minus 5. So in the place of x, we're going to replace that with 11. So I have 3 times 11 minus 5. What is 3 times 11? 33. And 33 minus 5? 28. So QB is 28. All right, we have one thing left to figure out. We want the measurement of angle PAQ. Angle PAQ is this whole big angle right here. What did we call this ray again? Angle bisector. What does an angle bisector do? Cuts it in half. So if this one is 29 degrees, how big is this one? 29. Also 29 degrees. So I could say the measurement of angle PAQ is equal to 2 times the measurement of angle PAB. Because I have two angles that are the same size right here. So the measurement of angle PAQ is equal to 2 times 29 degrees. What is 2 times 29? What is 2 times 29? 58. So angle PAQ is 58 degrees. Very nicely done. All right. So that's angle bisectors in a nutshell. The incenter of a triangle is the point of intersection of the three angle bisectors of a triangle. The incenter will be equidistant. What does equidistant mean again? Equal distance, same distance. It's equidistant from all three sides. Equidistant from all three sides. So we're going to draw in the angle bisectors and the incenter in this picture here. So I'm going to draw in the angle bisector for angle B. So that means this angle is congruent to this angle. The angle bisector for angle A. So this angle is congruent to this angle. And the angle bisector for angle C. So this little angle is congruent to this little angle. This point right here, where all three of those angle bisectors come together, is called the incenter. This is called the incenter. Now we're going to draw in segments that go from the incenter to the sides of the triangle. And where it comes down to meet the side of the triangle, it makes a right angle. Those three segments that go from the incenter to the sides of the triangle are all congruent. That's what this statement up here means. It is equidistant from all three sides. So these three segments are all the same size. We had something kind of similar looking to this when we looked at our perpendicular bisectors. We had right angles, but a perpendicular bisector doesn't just make a right angle. What does a bisector do? Cuts it in half. And so my perpendicular bisector would go through the midpoint of the side. Is this the midpoint of this side? Is it cutting it in half? No. This point right here is not a midpoint. Same thing with this point over here. This is also not a midpoint. And up here, this is not a midpoint. So with my angle bisectors, my angles are being cut in half. We can still drop these lines down to the sides and make right triangles, but we are not hitting at the midpoint when I have an incenter. When I have a circumcenter with my perpendicular bisectors, then we're hitting at the midpoints. But an incenter does not do that. All right, let's look at an example. Let's look at number 6. We are on page 7 right now. It says that P is the incenter of triangle XYZ. So I'm going to draw a little arrow here. This is the incenter. Find, and that shouldn't say each, that should just say the measurement of angle LZP. Well, angle LZP LZP is this angle right here. I don't have a way to find missing angles on right triangles unless I know two of the angles. Do I know two angles on this little triangle here? Do I know two of the angles? Thank you. Do we know two of the angles of this triangle? Come on, guys. Hang with me. We got 3 days left. Do we know two of the angles on this triangle? No. I know the right angle because that's marked in the corner, but this 7.3 is segment ZP. Okay, so I've got to come up with another way of finding this angle right here. Again, this is the angle that I want. Because this is the incenter, that means segment XP would be called a what? Because this is the incenter, this segment right here is called what? Let's go back to our definition of incenter. The incenter is the point of intersection of what? Angle bisectors. This is the incenter. So what is this segment? It's an angle bisector. That means it's cutting angle X in half. And it tells me that this little piece over here is 24.6 degrees. So how big is this side over here? (24.6 degrees). So this whole big angle up at the top, if I look at the whole thing, how big is that whole angle? What do I do to find that angle? If I want this whole big angle up at the top, what do I do to find it? Add these two together. What do I get when I add those two together? (49.2), thank you. 49.2 degrees. All right, let's come down here. Because P is the incenter, what is the name for segment PY? Angle bisector. So if this little angle down here is 25.1 degrees, how big is this little angle right here? 25.1 degrees. So how big is the whole big angle down here? (50.2). We add those two little angles together. I'm going to sketch this triangle off to the side without the incenter drawn in. So I have X up here, I have Y here, I have Z here. We said this angle up at the top was 49.2 degrees. And this angle over here was 50.2 degrees. What can I do to find this third angle here? What can I do to find the third angle? Three angles of a triangle add to 180. So what can I do? Yes, we're going to add these two angles. We're going to include that one over there, and then we're going to equal it to 180. So I can say 49.2 degrees plus 50.2 degrees plus the measure of angle XZY is equal to 180. Then we're going to combine our like terms together. What do we get when we combine 49.2 and 50.2? What is 49.2 plus 50.2? 99.4 plus the measure of angle XZY is equal to 180. Then I'm going to subtract 99.4 from both sides. What is 180 minus 99.4? 80.6. So this angle right here is 80.6 degrees. That's this whole angle right here. 80.6 degrees. But I don't want that whole angle. I just want this little piece of it right here. What do I need to do to find that little piece? Divide it by 2, yes. The measure of angle LZP is equal to half the measure of angle XZY. So the measure of angle LZP is equal to half of 80.6. What is half of 80.6? What is half of 80.6? 40.3. Nicely done. Cut it for me. Cut it for me. All right, let's go look at number 7. Number 7. Find each measure if J is the incenter of triangle ABC. So this right here is the incenter. If that is the incenter, then what is this segment called? Angle bisector. What is this segment called? Angle bisector. What about segment BJ? What is that segment called? Angle bisector. That means that these 3 segments, EJ, JD, and JF, are congruent. Those are going from the incenter to the side, and it's making a right angle where it hits the side. They want me to find segment DJ. We just said that segment DJ is the same as JE, is the same as JF. I can't use this triangle right here to find this side because I don't know how big any of the sides are. But on this triangle, I know 2 of the sides. And EJ is the same size as DJ. What formula can I use to find missing sides on right triangles? What formula can I use to find missing sides on right triangles? Starts with a P. Pythagorean theorem. So we're going to do Pythagorean theorem, a squared plus b squared equals c squared. C has to be the hypotenuse, which is opposite the right angle. So this 10.6 is the hypotenuse. So I'm going to put that in for C. So I would have 10.6 squared. One of my other sides, one of my legs is JE, so I can put JE in for either A or B. The other side is 9.4. So I have JE squared plus 9.4 squared equals 10.6 squared. 9.4 squared is 88.36. 10.6 squared is 112.36. Then I subtract 88.36 from both sides. So I get JE squared equals 24. Then we do the square root of both sides to get rid of the squared on JE. Cancels out the squared and the square root over on the left. We get two answers when we do this, but only the positive answer makes sense. I get 4.899. And we said that DJ is congruent to JE. So the length of DJ is equal to the length of JE. So DJ is also 4.899. We will find the measurement of angle JAC tomorrow along with number 8. I am going to push your homework off to being due until Friday because we did not get through all the examples that I wanted to get through today. So you get one extra day on the homework. Homework is due on Friday. Your first skills check of the module will also be on Friday. Homework is due on Friday. Skills check on Friday.